Hello everyone, welcome back. So today I will be continuing with that linked list series I have been doing. So today's problem is called copy list with random pointers. This is a very tricky problem I would say, but a very important one for you interviews to know. So let's go through the problem statement once. It says a linked list is given such that each node contains an additional random pointer which could point to any node in the list. Return a deep copy of the list. So basically what he's saying is we will be given with a head of a linked list which will be a singly linked list with a simple twist in it where the class structure or the node structure will have another pointer called random. So as we can see from this example, this is a singly linked list where it has another pointer called random. So this random pointer can point to any of the other nodes present in the linked list. So we have to just copy or rather make a deep copy of this linked list without making any changes to this original list. So we have to make another linked list without changing this linked list, and we have to return the head of that linked list. So we can see that examples are given over here. So here we can see that value is an integer represented by node.value random index. So this random index means what? At any node, let's say here 13 comma 0, that means the random pointer of the node 13 is pointing to 0th node, which is 7 in this case. So that will be given to us. Or if nothing is, let's say for this node like 7, so the random pointer is pointing to null. So in that case, at the place of index, the null will be given. So now we have to just make this whole copy of this random list, and we have to return the head of that new constructed list. Over here, we can see in the constraints, the value of the nodes can be like minus 10,000 to 10,000. So basically, this value doesn't matter for this problem, but it is good to know. And node.random is null or pointing to any other linked list. So there can be cases where node.random is null and number of nodes can be 1000. So this is our problem statement. Now let us just go to the whiteboard and let's see how to solve this problem. So here I have written down the class structure of the new type of node. Over here we can see this class is called node and it has three attributes. One is value, one is the next node, and one is the random node. So the node kind of looks like this. So I have taken this example from LeetCode where we can see clearly it's a singly linked list and every next node is pointing to the next value, like 7 dot next is 13, 13 dot next is 11. But here also we have another node called random. So for this example, 7 dot random is pointing to null. Here 13 dot random, here we can see pointing to 7. So here like this, every node random has to point to either null or something, some other nodes from this linked list. So it cannot be like it would be pointing to any other list. Like it has to, this random node has to point to some other node in this linked list. Like for each node, the random pointer can point to null or any other node in this linked list. So I guess the problem is pretty straightforward. So how to solve this problem or how to approach this problem? So one basic or first solution which came to our mind is, let's say if we make a map of the current node of the given list and the new node which we are going to generate. So let me just write down over here how this map will look like. So we will be using a hash map or Python dictionary. So here it will be a map or hash table also, we can say. So here it would be key and here it would be value. So what our key will be, our key will be the nodes from this list, and our value will be our newly generated list, which will be having same value as this node which is given to as input. So let's say we are started traversing this list and we have made a new node for each node we encounter in this previous list. So let's say first we encounter 7. So let me draw it like this. 7. For 7 we have made a similar node in our value which is also 7. So exactly like this we will do for all the other nodes over here, 13, 11 and so on. So let me do that quickly. Like 13, for 13. I'm not drawing this box again and again, so here will be same thing, 13, then 11, 11, 10, 10, 1, 1, and then it's null. So we have all our nodes. So now after mapping, these are new nodes. These are new nodes where this next pointer and the random pointer is not connected to any of these nodes, but here all the pointers are connected because this is our input list, right? This is our input list. So this is our input list. Here all the pointers are connected. So now we have to do what? Basically traverse this one and compare with its pointers and connect the pointers for the new nodes. And how that is going to happen is, let's say first we traverse through this list. We traverse through the given list. First of all, let's say head is over here. We started with head. So no, we have to take one variable. Let's say current. So current is equal to head and current is over here. So first we will check what is the node which is corresponding to the key current in our hash map. So that node is this new node called 7. So let's say if our variable is called map, so map of current will be the new node. So we have to now make changes to the pointers. So we have to now point the new nodes next equal to something and map dot current, it would return the new node and it's random to something. So what this something will be, now we have to find out. So let's say we are at 7. So 7, we go to the map, we found the corresponding new node. So this new nodes next will be pointing to this nodes next, right? So how to find this nodes next? Because the next node will be this node, so we can straightly go to this node in the key and return its value, so which will indeed be this node. So by doing this we can literally connecting like this, because this new nodes connection will be connected with the value of this node's key. So you're understanding, I guess. So here we have to write map dot current dot next, and we have to similarly write map dot current dot random. So basically these two lines will do what? Populate all the pointers of the new list, which compared to same as the previous list. But here we have to check two edge cases. Once where let's say this current dot next is, for this case, for this node, current dot next is null. So there we aren't storing any null key over here. So for that we have to check one if condition over here. If current dot next equals to none, then we do what? Then we make this variable is equals to none, or else this. Same thing we have to check for this random also. If current dot random is equals to none. So current dot random is none for this case. Over here we can see 7 dot random is here, null or none, this is same. So we have no none node over here. So we have to make what? We have to make this thing as none. We have to make this thing as none, or else it would be this map of current dot random. So this is the gist of our solution, which is approach 1. So what would be the time and space complexity with this solution? What we are going to do is we are first traversing this whole list using one pass, that would be order of n, and we are storing this in the map, and this map can have at most the total number of nodes present in the linked list. So the time complexity will be order of n and the space complexity will also be order of n. And here also for populating the new list we are also traversing this list once more, so that's why it will be order of n plus order of n. So we can actually do better than this approach, where we will be using this, reducing the space complexity to constant space. We will not be using this map, but instead we will be doing one another extra pass. So the time complexity will be, in general, we can say worst case order of n, and space complexity will be order of 1. So we can do like this. So now I will be discussing this better approach. So in the code editor, first I will show you the code of this solution where we are going to use a map. Then I will again come to the whiteboard and explain you how to solve it using constant space. So let's go to code editor, and now let's see how to code this. The video may get very long, so that's why I will not writing the code live. Instead, I will be explaining my previously written code. So here we can see the approach which just I have explained. First of all, we are creating this dictionary called copy map, and we are having a current variable uh, in which we are storing the head, which is called current. So this is the first pass where we are doing what? We are just making a new node, which indeed called a new node, and we are storing with respect to key of current node. So with current node key, the value will be stored is a new node. So this is one pass to populate the copy map. After that, we will be doing another pass where again we have current as head, and here we first check, as I have already told, that if the current dot next is none, which is indeed for this node over here, we can see for one the current dot next is none. So for that we don't have any key, so that's why we straightly do what? Copy map of current, which will give us the new node, and we will make its next pointer as none. Or else we will do what? Copy map of current, which will give us the new node dot next is equal to copy map of current dot next. Because let's say, for I've already explained that in whiteboard, so you can understand easily, and we are doing the same thing for the random pointer over here also, and we are just incrementing the current to current dot next, and after that we are just returning the copy map of head. So this head will be returning that the new node of the newly created linked list, and we haven't even like change the previously given input linked list. So that's why our solution works, and if I submit it, you can see that it gets accepted. And I have also explained the time and space complexity. We can see it's accepted. So now let's go to the whiteboard again, and let's see how we can do it in less space, like order of one constant space. Now, the space efficient approach, which I will be explaining right now, that works in constant space, is not something which anyone can really come up with in an interview, but it is very good to know if the interviewer asks for further optimization. So I have written this linked list down in a simpler way because it has many pointer manipulation in this approach, so it can get a little messy. So, but the node structure is again similar to this. So I have just replaced it with a circle so that it's easier to see. So what in this approach we are going to do is we will be not using any map. So without using any map, somehow we have to find a way where the newly created node is somehow linked with the previous nodes. So how this approach will work is, let's say we have this node again, these nodes over here again written like this: 7, 13, 11, let's say 11, 10, 1, none. So these are the nodes. Okay, so let me circle it like this. So what we will do is, we will make a new node in between, or rather next to the previous node. Let's say we have 7, so we will make a new node over here. So this will be a new node. So after creating a new node, if let's say this is the current, this is the current, so what we will do is, we will make first of all the new nodes next as current dot next. So we will connect first of all this node with this, and we will make the previously that this node was connected like this, right? Because it was this list, because you can see this is connected like this. But as we have connected this dot next is current dot next, so we have to remove this, and we have to connect the next to this node. So basically we are doing what? We are putting a new node with this node same value in between these two nodes, like just after the previous node, and we will do the same thing for all the nodes like this: 11, 10, 1, and none. So here we can see at every even index we are having new nodes, every even index. After that we will have a list like this. Okay, so this is so far so good. Okay, after that what we have to do is basically, so for creating this list we have to also increment this current two values. First current was here. After making of this node, there is no point of moving this current to over here because this is a new node. So we have to do what? We have to move this current. Current is equal to current dot next dot next. So now the current will be here, the current will be here, and we do the same process for creating this linked list. So after creating this, now we have simply, we just have to do what? We have to point the random pointers, because these are the current nodes, right? So these nodes random pointers are already connected like this as the previous node. This 7 is connected to none, this 13 is connected to, this 13 is connected to 7. Now this 11 is connected to, the old 11 is connected to old 1. The old 1 over here, let's say, is connected to 0. So this old 1 is now connected to 7. This again, this 10 is connected to 11, this 10 is connected to 11. So this is how all the random pointers are already connected. So now what we have to do is basically connect the random pointers of these new nodes. So how we are going to connect the random pointers of these new nodes? So okay, so again we have a current pointer pointing to here, which was the previously previous nodes head. So after that we will do what? We will do for pointing the random pointer of this newly connected node, we will do what? Current dot next. So what is current dot next? Current dot next is this new node. So we have to now point current dot next random. So current dot next random will be current dot randoms next, will be current dot randoms next. And this is it pretty much, because let's go through one example quickly so we can understand it. So let's say for this example here, this 10 is connected with 11, right? So we also have to make this new node 10 connect to this new node 11 like this. So how we are going to make this connection? So let's say the current pointer right now is at old 10. So old 10 dot next, which is indeed the new 10 from this. So its random pointer will be currents random dot next, which is this. So by doing this we are just connecting the new nodes random to the previous node, and we have connections for all these new nodes. So after that only one thing remains, and what is that? We have to now restore the previously given linked list. So that's why we have to just break down these connections, these links. So we are understanding like this current node is pointing to this, instead this one should pointing to previous node. So we have to just break these connections, and we have to make like this for every node, for every node, sorry, over here. So by this we are restoring the previous linked list, and we are also generating this new linked list, which looks like this: 7, then 13, then 11, then 10, then 1. So this is how we are going to solve this. So we will be having three simple linear passes through the linked list, and we will do the pointer manipulation. So this will take order of n time, but we are not using any space, so that's why order of one space, order of one space. So now let's go to the code editor and let me show you how this code will look like. This video is going very long, so that's why I will be quickly explaining this solution, which I have just explained in the whiteboard also. So first of all, as I've said, we will be having three passes. So first of all, this pass will be creating all the new nodes just next to the previous node. So we are creating this new node, and new node dot next is equal to current dot next as usual, and current dot next will be the new node. So that's why that means what, we are making a new node just right side of the previous nodes. After that, using this loop, we are doing what, we are connecting all the random pointers first. So for connecting the random pointers first, we have to check if there exists a random pointer for a current node. If not, we simply make it the none for the new node's random pointer also, or else we do what, we made current dot next dot random is current dot randoms next, which we are doing in this line over here. And after that, we just have to separate those two linked lists, one is new and one is old. For that case, we will do what, we will be having two nodes. What is, one is clone node over here, which is head of the clone linked list, which is head dot next. Another is current over here, which is the head of previous linked list. So current dot next will be current dot next dot next, because remember that a new node is in between them, so that's why we have to skip one element. And similarly, for the new nodes next, it will be skipping one old element and going to right. So if we just go back a little and watch my diagrams, you can clearly understand. And if you run through them yourself, you can also understand. So let me just quickly submit this code and let's see if it gets accepted or not. And as I've already told the time complexity, it has 3 order of n passes. So at most, at worst case, and this is also accepted, at most it will be big of n time complexity, and we are not using any extra spaces, so that's why we go of 1 space complexity. So thank you for watching. So this is how we can solve using 2 approaches, copy list with random pointers. This is a very important question to do for your interviews. So if you found this video helpful, please like and subscribe to my channel.